morning, students. Chapter 2, Units and Measurement. Yes, we have discussed three applications of dimensional analysis. First, to check dimensional consistency of given equation, then to obtain relation among physical quantities, and the last one is to obtain numerical relation between units of a same physical quantity. Okay, now yes, these three are applications, means we can solve questions based on it. Now there are some limitations of dimensional analysis. So yes, today's topic is limitations of dimensional analysis. See, numbers of limitations we have. First, yes, if you remember second method, that is to obtain relation between physical quantities. Okay, remember that example, that E is equal to 2 pi under root L upon G. Time period depends on mass, length and gravitational acceleration. So yes, we have to write equation, then put dimensional formula, and then compare powers of M, L and T. So yes, in any physical quantity, yes, if we compare powers of M, L and T, so we will get most three equations. Okay, by equating powers of M, L and T, we get most three equations. So if any physical quantity depends on more than three physical quantities, then it is not possible to derive relation between them. So yes, it is first limitation. Again, put dimensional formula, then you have to compare powers of M, L and T. M, L and T. You have to compare powers of M, L and T. So you will get maximum three equations. You will get maximum three equations. But if physical quantity depends on more than three physical quantities, yes, three equations, more than three variables, according to maths, you cannot find. You cannot find. Okay. So if a physical quantity depends on more than three quantities, then relation among them cannot be obtained. Clear? Why? What is reason? Because by equating powers of M, L and T, we get most three equations. Okay, so with the help of three equations, we cannot find more than three variables. So yes, it is first limitation. Okay, if a physical quantity depends on more than three quantities, okay, the relation among them cannot be obtained, because by equating powers of M, L and T, we get most three equations. Second one, information about dimensionless constant cannot be obtained. Okay, and yes, you know that equation, you know one relation, that is T is equal to 2 pi under root L upon G. Here we have considered K is equal to 2 pi with the help of experiments. We cannot get value of this K is equal to 2 pi with the help of dimensional analysis. Clear about this? So yes, second one is information about dimensionless constant cannot be obtain. That value of dimensionless constant you have to put with the help of experiments, okay, and as a result of experiments. Okay, now yes, third one is what is number 3? Yes, if dimensionless constant, if that constant of proportionality, yes, what is k? This k is constant of proportionality. If constant of proportionality is not dimensionless, means it has some dimensions, so to obtain that equation, dimensional analysis is not used. For example, in f is equal to g m1 m2 upon r square, g is not dimensionless. Here this g is not dimensionless because its unit is Newton meter square per kg square. So such equation cannot be obtained. Such equation cannot be obtained with the help of dimensional analysis. Clear about this? So yes, equation in which constant of proportionality, that is k, is not dimensionless, it has some unit, it has some dimension, that such equation cannot be obtained. Clear about this? So yes, these are 3 limitations of dimensional analysis. Now fourth one and last one, and yes, most important one. Okay, fourth one, limitations of dimensional analysis, that is dimensional analysis cannot be used to obtain relations involving dimensional analysis cannot be used to derive relations involving first trigonometrical, second exponential, and third one logarithmic functions. Okay, such functions are dimensionless. Okay, so yes, it is one important one. Okay, a dimensional analysis cannot be used to derive relation involving trigonometrical, exponential, and logarithmic functions. Such functions are dimensionless. How? If I have one function sine kx and e raised to minus kx. For example, it is sine omega t. So it is sine omega t and e raised to minus kx. Okay, or I have third equation, that is ln alpha t, log alpha t. So see, sine omega t is called trigonometric function. So in this trigonometric function, this omega t is dimensionless. Okay, e raised to minus kx, it is exponential function. So in this exponential function, in this trigonometric function, sine omega t means this angle is dimensionless. E raised to minus kx means power of e, that is kx, is dimensionless. And in this case, in log alpha t, this alpha t is dimensionless. Clear about this? So yes, you have to remember it is one important limitation. Okay. Okay. Yes, trigonometric functions, logarithmic functions, and exponential functions, they are dimensionless. So yes, I can write this as omega t is equal to 1. Means dimension of omega t is equal to 1. Dimensionless means m0 l0 t0. m0 l0 t0. Okay. So yes, you can write 1. Here it is kx is equal to, it is 1. Here this alpha t is equal to, it is 1. See, in dimensional analysis, we do not have to consider this negative sign. Clear about this? In dimensional analysis, we do not have to consider this such minus sign. Okay? So yes, these are 4 limitations of dimensional analysis. First, if a physical quantity depends on more than 3 quantities, then relation among them cannot be obtained, because we will get most 3 equations. Information about dimensionless constant cannot be obtained. Yes, we know that E k is equal to 2 pi. We have discussed that. Okay. F is equal to gm1 upon m2 upon r square. Yes, this constant of proportionality is not dimensionless. It has unique Newton meter square per kg square. So such equations cannot be obtained. Fourth one, important one, trigonometrical, exponential, and logarithmic function, they are dimensionless. Yes, they are dimensionless. Clear about this? So yes, you have to remember these 4 limitations of dimensional analysis. Okay, and now we will see some questions based on it. Now we will see some questions based on it. See, here it is. Equation of stationary wave y is equal to 2a sin kx cos omega t. Find dimensions of a upon k. Y is displacement, a amplitude, x distance, t is time. You have to find dimensions of a and k. You have to find dimensions of a and k. What is y? Y is displacement. A is amplitude. Now amplitude means what? Amplitude means maximum displacement. Amplitude means maximum displacement. Okay, so yes, here how to write? See, here it is. Y is equal to 2a sin kx cos omega t. A means it is amplitude. A means it is amplitude means maximum displacement. So dimensional formula of A is equal to displacement means it is L1. Displacement means it is L1. Yes, it is. Then you have to find dimensions of A upon K. I know what is dimension of A. Now how to find dimension of this K? See, K. Here it is in sin kx. First of all, you have to identify where is k. Yes, k is here. Sin kx. So see here, sin kx. Sin means trigonometric function. Trigonometric function is dimensionless. Yes, sin kx trigonometric function. It is dimensionless. So yes, how I can write this? I can write kx is equal to 1. So to find dimensional formula of k is equal to, it is 1 upon dimensional formula of x. So it is 1 upon, what is dimensional formula of x? X means distance. X means distance. Yes, x is distance. So dimensional formula of x is, it is L1. So I can write it is L minus 1. Simple. Okay, now as I have to find dimensions of A upon K, so dimensions of A upon K is equal to, what is dimension of A? L1. What is dimension of K? L minus 1. See, in numerator it is L1 and in denominator it is L minus 1. So, yes, L minus 1, if I take in numerator, it will become L1. So, it is L. It is your answer. Clear about this? So, yes, you can solve this question if you know limitations of dimensional analysis. If you know limitations of dimensional analysis. Clear about this? So, yes, limitations of dimensional analysis. One example based on it, we will see another questions. Okay, next question. See, P is equal to P0 exponential minus alpha t square, where P is pressure, alpha is constant, T is time. Find dimensional formula of alpha. You have to find the dimensional formula of alpha. See, this question is, here it is. P is equal to P0 exponential. I can write this equation as P is equal to P0 e raised to minus alpha t square. Okay, I can write this exp as e raised to minus alpha t square. You have to find dimensional formula of alpha. Where is alpha? Alpha is here as power of e. And yes, we know that e raised to minus alpha t square is exponential function and it is dimensionless. Clear about this? So yes, e raised to minus alpha t square is dimensionless. So how to write? Yes, dimensions of alpha t square is equal to 1. Yes, negative sign we do not have to consider. While dealing with dimensional formula. Okay, so yes, alpha t square is equal to 1. So dimension formula of alpha is equal to 1 upon dimensional formula of t square. So dimensional formula of alpha is equal to 1 upon t2 is equal to t minus 2. Yes, easy one, simple one. Okay, how to find dimensional formula of alpha. Clear about this? So yes, it is one easy example. Now next question. See, if energy E, momentum P and force F were to be chosen as fundamental units, what would be the dimensions of mass in a new system? See, you know dimensional formula of mass, that is M1. Yes, M1, L0, T0. But your question is, if energy, momentum and force was to be chosen as fundamental units, then what would be the dimensions of mass in the new system? See, you can solve this question with which application? Obviously with the help of second application. Now, how to solve this question? See, first of all, fundamental units, what would be the dimensions of mass in a new system? So yes, you have to write like this. Okay, mass M depends on energy E, momentum P and force F. So yes, I can write M is proportional to E raised to A, P raised to B and F raised to C. So yes, M is equal to E raised to K, E raised to A, P raised to B and F raised to C. Then what is K? Yes, K is dimensionless constant. K is dimensionless constant. K is dimensionless constant. Now, what we have to do? Yes, put dimensional formula on both sides. So yes, M is mass, so it is M1, L0, T0. K, dimensionless constant, so it is 1. E, energy, M1, L2, T minus 2 raised to A. P, linear momentum means it is M1, L1, T minus 1 raised to B. Yes, what is dimensional formula of momentum? P is equal to MV, and here it is dimensional formula of P. Force, it is M1, L1, T minus 2 raised to C. Yes, now we have to simplify this. C, M1, L0, T0 is equal to, how to simplify this? It is MA, L2A, T minus 2A. Here it is MB, LB, T minus B. Any doubt? Okay. Then here it is MC, LC and T minus C. Okay. So yes, now we have to set powers. That is M1, L0, T0 is equal to MA, MB, mc. So yes, here I have to write it is m, this to is a plus b plus c. Is it ma and b and mc? Next one is l. Yes, three terms, l2a, lb and lc. So l raised to, here it is l raised to, it is 2a plus, here it is b and here it is c. So it is plus b plus c. T raised to, yes t, again minus 2a minus b minus 2c. So here it is minus 2a minus b minus 2c. Clear about this? So yes, it is powers of m, l and t. Clear about this? So yes, left hand side, right hand side, dimensional formula are same. Dimensional formula are same. So yes, now you have to compare. Now you have to compare dimensions of. Now you have to compare dimensions of m, l and t. Now we have to compare dimensions of m, l and t. How to compare such dimensions? See, first of all m. What is power of m? This side it is a plus b plus c. This side it is 1. So it is equation number 1. Any doubt? Okay. Next one, equation number 2. Compare power of l. So power of l it is 2a plus b plus c is equal to power of l, it is 0. So it is equation number 2. It is equation number 2. Any doubt? Okay. Next one, power of t. Yes, here it is minus 2a minus 2a minus b minus 2c is equal to, what is power of c? What is power of t? Here it is 0. So it is equation number 3. So here it is equation number 3. Now yes, you have 3 equations. That is a plus b plus c is equal to 1. Then 2a plus b plus c is equal to 0. Then minus 2a minus b minus 2c is equal to 0. Now you have to obtain equation. Find a, b and c. How to find values of a, b and c? See, first of all, if I say equation 2 minus equation 1, equation 2 minus equation 1, how to find this? See, equation 2 minus equation 1. So it is 2a plus b plus c is equal to 0 minus, it is a plus b plus c is equal to 1. Yes, we have to take minus. So for minus it is minus, minus, and here it is minus. Here it will be minus. 2a minus a. So obviously it is a, b minus b 0, c minus c 0. 0 minus 1 it is minus 1. So what is value of a? A is equal to minus 1. What is value of a? A is equal to, it is minus 1. Any doubt? Any doubt? Yes. What is value of a? A is equal to, it is minus 1. Now you have to find values of b and c. Values of b and c. How to find values of b and c? See, here it is. If I add equation number 2 and equation number 3, equation 2 plus equation number 3. See, 2a cut, b cut, and c minus 2c. Means it is minus c is equal to 0. So therefore c is equal to, it is 0. Simple. C is equal to, it is 0. Then how to find value of b? Yes, we know that a plus b plus c is equal to, it is 1. A plus b plus c is equal to, it is 1. Then how to find value of, value of b? Yes, a, value of a is minus 1 plus b plus, what is value of c? It is 0, is equal to 1. So therefore b is equal to 1 plus 1. So therefore b is equal to, here it is, b is equal to, here it is. Clear about this? So yes, it is a is equal to minus 1, b is equal to 2, and c is equal to, it is 0. So yes, if you put values in this equation, you will get m is equal to, it is k. E raised to a means it is e raised to minus 1. P raised to b means it is p2. Okay, and f raised to c means it is f raised to 0. Okay, if I take dimension as constant 1, if a is equal to, it is 1, then yes, n is equal to, it is e raised to minus 1, p2, and here it is f 0. So it is dimensional formula of mass in with respect to energy, momentum, and force. Energy, momentum, and force. Clear about this? So yes, how to solve some equations, that is important. Okay, so yes, it is the whole topic, that is dimensional analysis. Okay, yes, for today, this is it.